Alright, so welcome everyone to the next lesson in this series, and in this video we will look at Kubernetes headless services. Now, in one of the previous lessons we looked at cluster IP services, and if you remember, when we configured the cluster IP service, it received an IP address from the cluster's service side range. Then kubeproxy configures the IP table rules that map the cluster IP to its backing endpoint so that when you target the IP address, traffic gets load balanced to those backing endpoints. Now, the difference between a cluster IP service and a headless service is that the headless service does not receive an IP address from the cluster's service side range. Instead, when you do a DNS lookup to a headless service, you are going to get the IP addresses of all the backing endpoints. So you directly connect to the backing endpoint without going through kubeproxy's IP table rules. Okay. Now, the common use case for headless services tend to be stateful applications in Kubernetes. Think about databases, Elasticsearch, and Kafka clusters. These type of workloads tend to have multiple stateful replicas that have to discover their peers as well as replicate amongst themselves. Now, another use case tends to be client-side load balancing. When you're going through cluster IP, you have basic round-robin load balancing, but if you want to implement some advanced load balancing capabilities at the client side, you could then leverage headless services as well, because the client will be able to discover all of the backend endpoints for that service. So in this lab, let's look at how headless services work under the hood. Let's get started. All right, I have already gone ahead and provisioned the lab. If you look at the folders, this lab can be found in 11-headless-services in the Git repo. And once you've provisioned the lab, you could inspect the lab topology to make sure everything is up and running. We have a simple 3-node kind cluster for this lab. Next, I'm going to look at the pods in the lab. We have several of them, the multi-tool pods, which we use for testing the Nginx deployment, as well as a Redis stateful set. So this is new for this lab. And if you do a kubectl get stateful set, you're going to see a 3 replica Redis stateful set that we will use to demonstrate the concept of headless services. All right, so let's move on. Next, what we're going to do is we're going to exec into one of the multi-tool pods. And sorry, before that, one more thing. We're going to look at the services configured in the cluster. So we have an Nginx service, and this is a cluster IP service. As you can see, it has an IP address of 1096, which is from within the cluster service side range. And for the same Nginx deployment, we've also configured a headless service. And this service has a cluster IP of none. Similarly, for the Redis stateful set, we have a headless service as well with a cluster IP of none. Now, when you look at the definition of a headless service and a cluster IP service, the main difference is in the cluster IP field, we specify none as the value for a headless service. Okay. All right, so let's exec back into the multi-tool pod, and we are going to run some DNS lookups. So the first one here is a DNS lookup for the Nginx cluster IP service. And we received an IP address of 1096.161.117, which was the IP address that we saw when we looked at the services as well. Now, this is a cluster IP, which is within the service side range for this cluster. Now, for the same Nginx deployment, we're going to do a DNS lookup for its headless service. And as a response, we receive the IP addresses of the 2 pods backing this Nginx service. So if you look at the side range, it is 192.168, which is the pod side range for this cluster. And next, I'm going to do similarly a lookup for the Redis headless service, and I receive the IPs of the 3 pods backing this Redis service. Okay, so this is the IP lookup difference between a cluster IP service and a headless service. For cluster IP, you receive the service IP. For headless services, you receive the IP addresses of the endpoints backing that service. Okay. Now, there is a difference between how the DNS entries are created for a headless service that is created out of a deployment and a headless service created out of a stateful set. Now, if I do a kubectl get pods, if you look at the pods of a deployment, their names are not deterministic. We have a hash that is suffixed to the name of the deployment as and when these pods are created, and that hash value is random. When you look at the name of a stateful set, it is deterministic. So we have the name of the stateful set followed by what is known as an ordinal. And the ordinals, they start with 0 and increment by 1 depending on the number of replicas for that stateful set. Now, this gets reflected in the way the endpoint slices are created for the service. Now, remember when we looked at the cluster IP services in a previous lesson, kubeproxy creates the IP table rules that translates the service to the backend endpoints, and it does the load balancing. Basically, the IP table rules do the load balancing. Now, kubeproxy, to configure those rules, consumes an object known as endpoint slices. Similarly, core DNS also watches endpoint slices. And if the endpoint slices have a host name configured, core DNS will configure a DNS record for those host names. So let's look at this. I'm going to first retrieve the endpoint slices for the Redis headless service. And when you look at these endpoint slices for each endpoint, as in each pod, back in that service, there is a host name. So for example, for endpoint 1, I have the IP address and I have a host name of Redis 0. For endpoint 2, Redis-1. For endpoint 3, Redis-2, etc. Now, if I look at the endpoint slice definition for the Nginx headless service, and remember the Nginx is a deployment, I don't see a host name for the respective endpoints back in that service. Now, the way this manifests itself when it comes to DNS, so let's exec back into the multi-tool pod. And given that we have individual host DNS record for the Redis endpoints, I can query those endpoints with their host names and receive, individual IP address. I can do DNS lookups for those individual host names. So for example, in this case, I'm doing a DNS lookup for Redis-0. Similarly, I could do a DNS lookup for Redis-1 and receive their individual IP addresses as well. So this helps setups like databases or anything that relies on peer discovery to discover individual peers based on the host names of those peers. Now, in this Redis deployment, the way we provide the host names is, if you look at the commands, it could be in the form of environment variables. We specified what the host name of the master would look like so that as the slaves come up, they are able to discover the master and connect with the master, okay? And depending on the type of application, they may have their kind of own internal mechanisms to discover their peers. But the important thing here is that when it comes to stateful sets, those host names are predictable. All right, so next let's do some experiments with this Redis setup. Like for example, if I do try to send a ping to Redis 0, I get a pong, I get a response, which means this cluster is up and running. And if you look at the replication information, the master here is able to identify and discover the slaves in the cluster, and we see the respective host names for those slaves here as well. Similarly, if I look at the replication information for a slave, in this case, Redis-1, we can see that it successfully discovered the master as well because the host name to do so was provided as part of that Redis deployment. All right, so as an experiment, what we can do next is if we are to, let's say, populate this database, with some information here. So we've set a key with hello from master, and we populated that in Redis-0, which is the master, and I can retrieve that from Redis-1 as an example and Redis-2 as an example as well, which demonstrates that replication is successfully working via headless services for this Redis setup. Okay. All right, so in the lab guide, I've given some other instructions so that you can play around, with this Redis cluster. But what I want to do next for this video is we are going to exec from this multi-tool pod and exec into one of our nodes. And what you're going to notice is, so let me exec into a worker node. and we are going to retrieve the IP table rules for the Nginx cluster IP service. And you can see that, we have IP table rules, and in the cluster IP lesson, we showed how you could navigate these IP table rules, okay? This is important to understand the inner workings of how services are configured under the hood in Kubernetes. Now, if I try to retrieve the rules for headless services, I'm not going to find any. And that's because kubeproxy does not configure IP table rules for headless services. Why? Because the headless services don't have a cluster IP. All right. That's it for this lesson on headless services. I hope you now understand the difference between a cluster IP service and a headless service and the use case for both those types of services. I'll see you in the next one. Thanks for watching, and bye for now.